Hello guys, welcome back again to another video of your class 12 mathematics. In today's video we shall be studying about calculus, and it's all about your exercise 5.7. That's nothing more than your second order differentiation. Okay, before I begin with the second order differentiation, till now we have been doing the first order differentiation. That is nothing more than your dy by dx. Or I can say it's nothing more than your f dash x, or in simple words your y1. Okay, so that's nothing more than your first order differentiation. Okay, now if I give this one to be equation number 1, if I differentiate equation 1 with respect to x, I'll be getting nothing more than your d by dx of your dy by dx, and similarly it will be d by dx of your f dash x. So that will be nothing more than d square y divided by dx square is equal to your f double dash x, and that is nothing more than your second order differentiation. I hope you're clear till there. So this one, it is read as nothing more than your d square y over d x square. So that's all about the starting of your second order differentiation. So let me go to your question. So your exercise 5.7, your question is given to be find the second order derivative or differentiation, same thing, of the function. So given from question number 1 till question number 9. All right, so if I happen to do question number 1, your question number 1 is given to be nothing more than your x square plus 3x plus 2. So let me just say let y is equal to your x square plus 3x plus 2. So if I differentiate both with respect to x, I'll get here nothing more than dy by dx is equal to d by dx of your x square plus 3x plus 2, which would be nothing more than 2x plus 3. So remember that this one is nothing more than your first order. Clear? So in short, I got here dy by dx to be nothing more than 2x plus 3. Let me give this one to be question number 1. Again, differentiating equation 1 with respect to x. So if I differentiate, I'll get here d by dx of here dy by dx, which would be nothing more than d by dx of your 2x plus 3. So the answer would be 2. So in short, that is d square y divided by dx square, or d2y divided by dx square, something, is equal to 2. So that's your answer. You can pause the video and then check. So that was all about your question number 1. In a similar manner, let me do question number 3. Your question number 3, let me just start with let y is equal to x cos x. So I got two terms. In short, I have to use the product rule. So differentiating both with respect to x. If I differentiate with respect to x, I'll get here dy by dx is equal to d by dx of your x cos x. So if I happen to use the product rule, it will be x d by dx of your cos x plus cos x d by dx of your x. So in short, your dy by dx happens to be nothing more than minus x sine x, because d by dx of your cos x is nothing more than minus sine x plus cos x. So give this one to be equation number 1. Again, differentiating equation 1 with respect to x. If we differentiate equation with respect to x, I'll get here d by dx of your dy by dx is equal to d by dx of your minus x sine x plus cos x. Remember, for this one, I have to use the product rule. Why? Because I got two terms over there. So that your answer would be minus x d by dx of your sine x plus d by dx. Okay, I'll just take minus commons. I'll just give bracket. So d by dx of your x, here should be your sine x, and then plus d by dx of your cos x. You should close the bracket over here, and then I'll get this one. So that I'll get the answer, nothing more than minus x cos x in bracket plus sine x into 1, again minus sine x. So in short, your d square y by dx square is nothing more than minus x cos x minus sine x minus sine x. So which would be, if I take your minus common, so that will be nothing more than x cos x plus 2 sine x, and that's your answer. You pause the video and then check once again. So that was all about your question number 3. So in a similar manner, let me do your question number 4. Your question number 4 happens to be your log x. So same thing, let y is equal to your log x, and then differentiating both with respect to x, I'll get here dy by dx is equal to d by dx of your log x. D by dx of log x is nothing more than 1 by x. So in short, I got dy by dx to be 1 by x. Let me give you question number 1. So again, differentiating equation 1 with respect to x. If I differentiate equation 1 with respect to x, I'll get here d by dx of your dy by dx is equal to d by dx of your 1 by x. So in short, I have to use the quotient rule. So that will be nothing more than x d by dx of 1 minus 1 d by dx of your x divided by your x square. So which would be nothing more than 0 minus 1 divided by x square. So in short, minus 1 by x square. So I got your answer over here, d square y by your dx square. So that's your answer. You can pause the video and then check once again how to do this one. I guess you're clear. All right, let me just again jump to your question number 8. Your question number 8 happens to be your tan inverse x. So similarly, let y is equal to your tan inverse x. So if y is equal to tan inverse x, so if you differentiate both with respect to x, I'll get here dy by dx is equal to d by dx of your tan inverse x. So d by dx of your tan inverse x is nothing more than 1 by 1 plus x squared. So let me just give equation 1. So again, differentiating equation 1 with respect to x, I'll get here d by dx of your dy by dx equal to d by dx of your 1 divided by 1 plus x squared. Again, the same thing, I have to use nothing more than your quotient rule. So if I happen to use the quotient rule, I'll get here nothing more than 1 plus x squared, and then d by dx of 1 minus 1 d by dx of your 1 plus x squared, and then divided by 1 plus x squared, the whole thing square. So which would be nothing more than 0 minus 2x divided by 1 plus x squared, the whole thing square. So in short, therefore d square y by dx square is nothing more than minus 2x divided by 1 plus x square, the whole thing square. So that's your answer for your question number 8. You can pause the video and then check once again. So that was all about your question number 8. All right, again, in the same way, let me try to do your question number 11. Your question number 11 is given to be if y is equal to 5 cos x minus 3 sin x. I have to prove that your d square y by your dx square plus y is equal to 0. All right, so let me give equation number 1. So if I differentiate equation number 1 with respect to x, if I differentiate equation number 1 with respect to x, I'll get here nothing more than dy by dx is equal to d by dx of your 5 cos x minus 3 sin x in bracket. So if I differentiate d by dx of a cos x, I'll get here minus 5 sin x. Similarly, d by dx of your sin x, it will be minus 3 cos x. So let me just be equation number 2. So again, differentiating equation 2 with respect to x. If you differentiate equation 2 with respect to x, I'll get here d by dx of your dy by dx is equal to nothing more than d by dx of your minus 5 sin x minus 3 cos x. So if I happen to differentiate this with this one, I'll get here nothing more than minus 5 cos x, and similarly this with this one, I'll get here plus 3 sin x. So let me take on your left hand side. Your left hand side is given to be your d square y by dx square plus y is, so which is nothing more than your d square y by dx square happens to be this one. So I'll just write on the same thing, minus 5 cos x plus 3 sin x. And in a similar way, the value for y happens to be this one. So that will be nothing more than 5 cos x minus 3 sin x. So I can cancel this with this and then this with this. I'll get the answer 0, which happens to be your right hand side. So therefore, left hand side is equal to your right hand side. So hence proof. Again, the same thing. You can pause the video and then check once again. So that was all about your question number 11. Okay, let me again jump to your question number 15. Your question number 15 is given to be nothing more than y is equal to 500 e to the power 7x plus 600 e to the power minus 7x. I have to show that your d square y by your dx square is equal to your 49y. Alright, again the same thing. If I differentiate this one with respect to differentiating equation 1 with respect to x, I'll get here dy by dx, which is nothing more than d by dx of your 500 e to the power 7x plus 600 e to the power minus 7x. So which would be 500 e to the power 7x into d by dx of your 7x. Why? Because there's not x. And then similarly, if I differentiate this one along with this, I'll get here 600 e to the power minus 7x, but there's not x. I have to differentiate once again. So in short, your dy by dx happens to be nothing more than 7 into 500 is, yeah, I can just, instead of multiplying, I'll just do like this, 500 into e to the power 7x into 7, and then plus 600 e to the power minus 7x into minus 7. All right, so that's your dy by dx. So again, differentiating, let me just give equation number 2. equation 2 with respect to x. So if I do that, from if you can look from here, I can take 7 common, right? So I'll just do that. Okay, so d by dx of your dy by dx is equal to 7, and then d by dx of your 500 e to the power 7x plus 600 e to the power minus 7x. So sorry, that shouldn't be your plus, that should actually be your minus. Why minus? It's because minus into plus is nothing more than your minus. So that's your minus. Okay, so I got here d square y by dx square is equal to 7. Again, the same thing. If I differentiate that, I'll get here 500 into e to the power 7x into 7 minus 600 e to the power minus 7x into minus 7. So if I take 7 common again, so that will be 49, and then 500 e to the power 7x minus into minus, see, minus into minus, it's nothing more than plus 600 into e to the power minus 7x. So which is 49y. From where? Since from equation 1. So I got here d square y by dx square. So hence proof. You can pause the video and then check once again. So that was all about your question number 15. Okay,